All right, just 1 or 2 seconds and we are live. Okay, hey everyone. It's Friday, it's 3 o'clock Berlin time, and it's another session of Amplifying F Sharp. Before we dive in, a little bit of housekeeping. As you know, we are an initiative from the community of F Sharp to drive the ecosystem, to maintain the ecosystem. So if you have any feature, any bug you like to work on, if you like to dive into something, get in contact with us. You can go to our website. Let me show you. And you can hand in a session in the upper right corner. You can tell us what you want to do. And yeah, we will get back to you and yeah, talk about the details and hopefully have something like today. Today is something special because it's just the second time in history of amplifying F sharp where we combine F sharp and actual hardware in a session in a project. So yeah, it's quite exciting. Um, and without further ado, I give it up to Mr. Ronald and Safer, who will tell us all about the Pixel Clock project.
Hi guys.
Hey everyone. So yeah, thank you, David. Thank you very much for introduction. So we are quite a small group today, as it seems, but it's very nice. Hello everyone. So yeah, today it's all about the pixel clock. I mean, I just let me just introduce the pixel clock a little bit. But before I introduce, let me say so. So what's this session all about? I mean, we have. Can I touch it or will I die? Because,
I'm pretty sure you can. We will see.
so it's all about this. It's all about this thing basically. I actually I can touch it because I think we passed all the tests and it's all secure. But I won't do it. It's all about this thing. It's the pixel clock. Um, so it's a frame with some colorful LEDs that Sefa and I am building, engineering, producing, and hopefully one day, also in the near future, also selling.
Hopefully.
Hopefully, for sure. um, and this is a programmable device. So the thing that you see here, this is actually an application running, made by the one and only Urs Ensler. He's also participating today, and um, today it's about how you can program such animations. And there is, as usual, there's a lot of creativity coming up when you start coding these things. It's really having an idea and you are able to implement it. And today, as I, as I usually say, my animations they are really not so nice looking. Yeah, so I'm basically have enough with all the technical details, and they are not so really so super creative, but this is basically it's up to you to get creative. So what I will show is how you can get all the environment up and running, and then how you can, yeah, basically what are the concepts? What do you have to do to actually yeah, program some pixels? And this is basically the goal for the session today. And I will show some stuff. Then Urs will also show us his some of his works. He's doing a lot of stuff, and explain some things. And yeah, so it's basically a quite open session, I would say. Um, and yeah, let's just see where we will end up. Yeah. So that's it. If you have any questions, just interrupt. If I don't see it, Dave will just give me a trigger, and yeah, so it's just a ping pong between you and us. And yeah, so I would say let's start coding. So before we can actually code, we have to do some setup. This is a quite easy thing. So because I'm sharing, no, I'm not sharing the screen. Just a second. share that one and share it. All right. So so there is a repository on GitHub. Um, I think it was also mentioned in this in the description of the session. It's this pixel clock repo, and in that repo is basically there are a lot of examples and a lot of tools where you can start coding. And what you have to do is either you clone the repo, you need Visual Studio Code and .NET and Ionide. So Ionide is the extension for F Sharp. Or what you also can do is you just set up a code space, and here's everything you need to get, yeah, basically zero configuration, zero setup. For this session, I will just use my instance of Visual Studio Code, but for you to give you a hint how to start is basically make the code space. Then you have to, so it takes some time to set up. Then you have to open the build task. It's Control Shift B, or what is it on Mac?
I think Command Shift B.
Command Shift B. So the first thing you have to do is you have to start the simulator. So because until you have the real thing, you have to code in the simulator, but this is fun as well, I would say. Now, so the simulator will then run, and you can open in your browser. Maybe I make this side by side now so that you can see. So you can open in the browser the simulator. Yeah. And then what you can do is you just take an example. So under the F-sharp apps, there are also some experimental TypeScript apps, but currently they are not running. So we are focusing on F-sharp. So you can, for example, I don't know, just take whatever file, you make Control A and then Alt Enter. This is basically this starts a loop and sends your app to the simulator. Okay, here's nothing. So interesting. What else do we have? We have here something. We have some shapes. So it's all the same. There are a lot of FSX files. We will have a look at them now. Yeah, and you just evaluate these files and send them to the simulator. This is all you need. Yeah, this is all you need to get things up and running, and then you focus basically on the code. That's it. Now here we have some. Here we have some. I don't know. You can do a lot of stuff. So this is the setup. Now this is a setup that a minimal barrier setup or low barrier setup, I would say. Yeah. Yeah. So in order to do something on your own. I am using my instance of Visual Studio Code, but which is basically also the same. I have that URL in my browser. I can, I can just do the same stuff. Do the same stuff here. I have to start the simulator as well. And as we can see,
Reload it.
wonderful. Zephyr's my lifesaver. Yeah, and as you can see, it's basically the same as you see it in GitHub Codespace. So for this tutorial, I just have I've written a small watcher where you can just you do not have to evaluate the stuff manually. You just can basically save a file, and then this is taken and sent to the simulator. Yeah? All right, so this is how you can get all the stuff up and running. Now the thing is, how do you program some pixel apps? I mean, we have a matrix. It is 24 by 24 pixels, and each pixel has an RGB value and also an alpha value. Basically, yeah, the easiest thing you can do is just access some pixels. You can draw some pixels, and I will do it here. It is always like we have some scene and we send that to the simulator. This is just some boilerplate. maybe for now, just don't care. But what happens is basically inside of the scene, there you program your pixel apps. And I say now I want to make a pixel with coordinate 0, 0 and stroke yellow. That's it. And we see that we have a pixel here up in the right corner. So just to get an idea, this looks like imperative code, and it also is a little bit, but there is a analogy, analogy, yeah. And now think of what happens here, because this is important for later. What happens is if you have a list, yeah, this is a list in F sharp. In TypeScript, you would just use commas, for example, yeah. But you have a list, and a list is something that you yield values in. So we are yielding 1, we are yielding 2, we are yielding 3, and these values that are yielded are combined to a list. This is very simple. So we see this down here. Yeah, we have an int list with 3 values. I can even use the yield keyword, and this is exactly the same. It is just implicit. But a list is something that can be built up by yielding values. And this is a basic idea. So a scene in our pixel universe is something that can yield pixels, yeah, as we do here. I can also write yield pixel, yeah, and I save it. Okay, it's still yellow, yeah, but for example, I can use another pixel, a red one, and we see it on the upper right corner. Yeah? And this analogy is, I think, if you understand, okay, it's about just yielding pixels, yeah, then this is a good way of understanding how things work. And so, to sum up, a list is a comprehension that yields elements and returns these elements in a list. Yeah? And a scene is a scene comprehension yields pixels and triggers side effects. Yeah? So it does not return an array or something like this, but it just triggers side effect. It could also return an array technically, yeah? But it just triggers some side effects so that we can see the stuff here on our canvas. Yeah? And the thing is, we can also yield, well, of course, we can yield more things. Yeah, we can yield more pixels. Yeah, but we can also yield a rectangle, for example. Yeah, a red rectangle that has these coordinates. Yeah, width, height, and it starts in the center of the screen. Yeah, we are just yielding these things. As you might know from other languages, for example, C# has similar things in where you can have a method that is basically a generator. Yeah, you can also iterate over something. For example, I can say, I can say this. Yeah, I say I'm yielding 1, I'm yielding 2, I'm yielding 3, and then I'm looping over, let me say, 4 to 10, and I'm yielding X. So what we get here is we get a list. Yeah, we see it here as a result. We get a list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah? And of course, I can do the same. I can do the same here. Yeah? I say I loop from 0 to 23. Yeah? I can also say from 4 to 10 as we did above. And then I say I yield 1 pixel with the x coordinate we are iterating over, and y coordinate 3, and it should be blue violet. So I'm a little bit colorblind, so I mean, yeah, it looks like something's like violet. Yeah? We can of course do that with another line, no? Or I can also, yeah, I don't know, add 3 to this thing, maybe turn it to here a little bit. So
I can
yeah,
also just shut down.
and yeah, and this is a way to to really, I would say, do some very low level stateless stuff. I mean, of course I can also yield a background, yeah, and then the stuff turns white on the um, on the canvas. Yeah. Um, I can also now, for example, of course, I can now that you just see it, um, I can also send it to my pixel clock because I have one here. Yeah. Um, maybe I stop the screen sharing. So I switch the camera. Huh. So we have this clock. Yeah. So now what I have to do, I mean, now you can't see my screen anymore. But first, I have to turn the canvas off. This is just a simple request via HTTP, and then I save. I cannot share my screen and show the pixel clock. No. Okay. Anyway, I make save, and you can see. Do you see it?
Yep, we
Yeah.
can see it.
Ah, wonderful. I mean, this is really doesn't look so yeah, so super fancy. As I said, I'm not an artist, but maybe Mark, maybe Mark is much better at this, or for sure, Mark is much better than this than I am. But you know, it's always this teaming up. Teaming up is really a nice experience because yeah, everyone um, can participate, and this is something that I value a lot. Is like we throw all the stuff together, and then something cool comes out. Yeah. Um, yeah, so so I will also in this talk I will really switch sometimes from the clock to my screen and forth and back and so on. So now I have to share the screen again. Hi Edgar, what's up?
Hello. Hello, everyone.
Hi, hi. Ah, okay. So, all right, Edgar, we just painted some nice pixels on some canvas, and I think it's very beautiful. Joking. And okay, but yeah, this is now what's important is this. It looks like imperative code. Actually, it is a mix of yeah, descriptive code and imperative code. Yeah, but it has some parallels to how I make a list. Yeah, this is something that we should remember because this gets important when we are dealing with state. Yeah, um, which we will do very soon. So, all right, now that we can do some primitive stuff, um, let me maybe just yeah, we can also yeah, we can draw some shapes. We had that we can draw, I don't know, some polygons. As I said, this looks very ugly. But I mean so we can make a circle, yeah, we can make the stuff I don't know, turn off anti-aliasing, for example, um, and so on. So I mean, the API that you see here is far from complete. Is basically, I mean, if I program some stuff or Urs is programming some stuff, and then we understand, okay, there could be some more stuff. But yeah, we are working on this. By the way, the API that you see here is also open source. I will tell that a little bit later, but it's possible to participate to just enhance this API and this kind of ecosystem, let me say. Yeah. Um, yeah, of course we can also yeah, we can draw some text. Yeah, it's the same as we usually have. Yeah, we just yield some text elements. You could say, yeah, in that manner. Um, of course, F sharp is a very clean and easy language. So this is just a function, just for people who are not so familiar with F sharp. So what we define here, this is a function that takes a row as a function parameter, and that parameter is used to multiply yeah, the a font height value, yeah, so that we can just have some rows. This is really quite low level, but it's working. It is working for this 24 by 24 canvas. Yeah. Um, mm, just a side note. I mean, you could also you unfortunately my but you know, for the people who are not so familiar with F sharp, you see F sharp understands that this must be a float, for example, yeah, um, or that I don't know, this can be some. Okay, this is still float. So the compiler always infers just from the usage, yeah, infers what your things are. Yeah? So it looks really like Python, for example, yeah, but it is very yeah, it is strongly typed, I would say. Yeah, so very very strong type. So for example, this
We
would
have
not work.
a small question in the chat.
Yeah, go ahead.
DML asks, what is the get CTX about?
Get CTX I do not see here. Um, we will get to that later.
Okay.
Quite soon. Yeah, quite soon. I will explain what it is. It is an you can access a context. This is not a static context then that you can use to retrieve several information about what's the size of your clock and so on. We'll get to that. But what I wanted to say now is um, that this is a function. It takes a parameter. It must be a float. You can call a function just by space. So function application is just a space. Yeah. Here the compiler would say, "Hey, bro, it should be a float, but here's a string." Yeah. Of course, parentheses also work in a mathematical way. Yeah, that you can control precedence. Yeah, but I can say 34.0. Yeah, I can write it like this. Or I can also write it with parentheses, then it looks like a yeah, usual C-style function call. Yeah? Just for the people who are not so familiar with F sharp, maybe. But um, or you could also, you know, have a more this is really the same, but here we just have a lambda there, and this is just a little bit of syntax sugar, which means the same. Yeah. All right. So, um, yeah, we can draw text. Yeah, we can draw text, and we can just use some very, very, very simple functions to yeah make our lives easier. Yeah, that's the idea here. Um, now let's have a look at something else. Let's go back. Let's go back to this example. Yeah? Um, so the thing is, this is a very beautiful example, but um, it is static, you know? I mean, this is obviously not moving, yeah? And but we usually we want to have some animations. And animations can be um, you just calculate some values um, based on, let me say, based on available values in your environment. Yeah. But so, for example, yeah, we could access the current date or current time, and we could I don't know make the x coordinate. Yeah, we could really do that here. Yeah, I could say this is a second. Yeah, uh, yeah, and we could, for example, um, yeah, we could say this, and we would say now, yeah, for the yellow. 1 second divided by 3.
Yeah, it's working.
Yeah.
Every 3 seconds it's
Yeah,
delivering one.
yeah. This is exactly 24. Yeah, okay. I think it's it. Or maybe we could, I mean, we could yeah, it will go out now, but it's a little bit quicker. It's a little bit quicker. Yeah, so we could do that. But I mean, here we have basically daytime now is really something that the environment provides, but this is not what we want to have. So usually all context, all context that we can access should be something like yeah, not dependent on a static value, but dependent on, yeah, I don't know, something that our runtime provides, not like this. Yeah. And for this, we have that context. Yeah. And the context also has a now, yeah, a now value. And it is working exactly in the same way. Mm, okay, we stick with that. It's working in the same way as daytime now, but only that there is somehow a magical value, that this context that we can access here. Yeah? And for now, we do not have to understand how that value comes into the system. It is just there. Yeah? Maybe if we have enough time, I will explain later a little bit how this is coming, how all this is working. But for now, it is, if you want to write these pixel apps and you want to access things like the current time, or for example, um, um, the dimensions of your pixel clock. You can all do it with this context value that you get, and you have to remember that you have to use an exclamation mark for this context. This is very important. Yeah. Um, so this is what the context means, and now we could also, for example, say.
So probably we can just say it provides you with some information about the current runtime, right?
Yeah,
It has some technical reasons. Maybe you will explain it later, but not now, I guess. So for rendering
yeah.
the stuff, pre-rendering it, yeah.
Exactly. This is exactly it. So, for example, we could just render it on a server, and you would get it. So this is the context. And when you want to program pixels, so for example, we could say now we are we are just replacing these values with height.
Sorry to interrupt, but we have a question from Marcos in the YouTube chat, and he asked if the device is already available anywhere.
Not yet. Not yet. Just a second.
We are working on it. We just passed the CE certification stuff, the EMI basically. And yeah,
that's it. We are working on it. So we hope to sell, so to start selling on yeah, maybe May or June, something like that. I mean, okay, we can just answer. So this is say yeah, yeah, just let me say we hope in May, something around in May, we can start selling at least the first batches. Yeah. So, I mean, to be honest, saying something about the clock, we are still we are building up this business, and we are still getting things up and running. It's a huge barrier that we have to take, because certification, safety, and all that stuff is a big topic that no matter how many units you sell, you have to do upfront. Yeah. We have to do some marketing things upfront and so on. So this is a huge block that luckily we almost mastered, I would say, at least for the first batches. And so I mean, if you want to know, just watch out for Pixel Clock, so PXL Clock hashtag on GitHub, Twitter, and Blue Sky, and all other stuff. So because we are announcing what's going on and the current state. Yeah, that's it. That's it for now. But yeah, soon we hope in spring that we start shipping the first units. So Urs and Dave, you are testers for us, basically, who are testing the product and helping to develop it. So this is the reason why you two guys, you have already your clocks, but it's not possible to buy, not yet. Yeah. But okay, I go on. The thing is, uh,
Maybe one thing I want to
yeah,
add.
tell.
If you're interested in buying one, just write us. That's very good feedback for us. So we actually know how many guys are interested in
Yeah,
and how many we will need to ship in the first batch. And that's a good information for us, actually.
yeah,
Also a motivation. I mean, it's both.
yes,
And it's a good feedback for us. So just write it in when you are currently watching on YouTube, maybe just write it in YouTube, reach out to us, whatever works for you
yeah,
guys. Yeah.
yeah, absolutely. Yeah, that's a cool thing. I mean, you can also, for example, you can check all the cumin and potato repos on GitHub uh, to get to contact us. I mean, we also have a Discord server running just to get in touch. It's all here on the Pixel Clock repo. Yeah, it would be really interesting who wants to buy such
Yeah,
a thing.
yeah,
Yeah,
absolutely. And also
yeah,
on GitHub, you will find resources for just getting started, right? And up and running with the simulator. Um, Ronald showed you in the beginning of the session. You don't even need to have it locally on your machine, but you can run it on GitHub Actions. I said no, no,
on
GitHub
code spaces.
code spaces. Yeah,
Yeah,
sorry.
exactly.
Um,
Yeah,
so it's an low barrier entry basically to get
yeah.
started.
Cool. All right. So let's focus this again. So this was the context. We'll also see it later. And now, but again, so we can somehow animate. We can somehow animate things depending on this. Yeah. On some values we get from the outer world by this context. But there's also another way of animating things. For example, I would like to, yeah, the big rectangle. I mean, also let me remove these things. They look very, very, not very beautiful. So, for example, the big rectangle in the middle, I would like to, fade in and fade out. This is obviously an animation. We could let it depend on the current time, but we do not want that. We just say it should just, start fading in and fading out. So what we need basically is we want to have an animated value where we can set the, for example, set the opacity of the color from our rectangle. Um,
One at
yes.
one. As your camera is still showing the real clock device, the viewers might be confused between code and what it does.
Thank
So
you.
maybe switch back to you two guys.
I mean, I'm sharing the screen now.
Your camera. I think you should be able to switch it to your face.
That you mean. All right.
Yeah.
Yes.
But you also see the screen, right?
Yes. Yes.
Okay.
Okay. Yeah.
Yeah.
Okay, now we are here live in color. Hey, okay. Very good. Thank you very much. So what, so we would like to have a value. Yeah. Um, Let me call it rect opacity. It's 0. Yeah. Rect opacity. Yeah. Now it's 0. Now we could say this is a value from 0 to 1. Yeah. And we would like to animate that value. So how can we do it? So this is and now this involves some state, but there's a very easy helper. There are a lot of ways to do it. And now what I will introduce is a concept that you might be familiar from some web frameworks or UI frameworks is we have to declare some state, yeah, that we can change, and we just preserve that state somewhere here. Yeah? And this is also very easy. And I say rect opacity is, and now I say use state and this. Yeah? For example, I start with 0. And this basically means start with 0 and somehow keep something. Yeah, keep something from evaluation to evaluation. I also have to change that here. I have to say the opacity is rect opacity dot value, and now I have to increment it. Mm, for example, by or maybe, but yeah, maybe by that value. And what does that mean now? So let me try to explain. This thing here is basically this is a loop. Yeah. So this is a computation. Yeah? This is a computation that gets executed 40 times per second. So we have just a one-step simulation, basically. Yeah? And that one-step simulation, it runs just with the frames per second of our device, which is currently 40 frames per second. And usually we would so we want to preserve something now because fading things in and out based on a last value, not based on a given value like here. It's just based on the last value. We want to refer to a last value and add something to it and preserve that added value until we are in the next cycle. Yeah, so we want to preserve a value from cycle to cycle. And similar concept is, for example, with React. Yeah, when you make an app in React and you say use state, basically you also do the same. You preserve something from one cycle to another cycle, but these cycles they are not they are triggered by an event. Yeah, for example, a click event or whatever when you want to rebuild the screen. And here they're just triggered 40 times per second, but the concept is very similar. Yeah, so and what we do not need is we do not need to create an instance of an object and address that object. We just do that inline. Yeah. So here we have basically we create an instance and we can already address that instance. Yeah. So this is the thing. So yeah, I save that, and I think what we see here. Yeah, okay. This is just fading in until yeah, until it's 1. Yeah. Um, Wonderful. So what we say here, for the people who are not so familiar with F sharp, this is expression based. So this is a assignment operator, and we say we want to assign this expression. Yeah, and this expression is we calculate a value and we return a value. Yeah, this is also an expression. This is also a value. Yeah, if value is bigger than 1, then 0, else we just take the value. I hope this is somehow clear. Yeah, maybe in yeah, you would I don't know, you would also in C sharp you would or in TypeScript, yeah, you would basically yeah, you would do that, yeah, but here we have expressions and we just say that. Yeah, so I save it, and what happens? It's blinking. Wonderful, it's blinking. Yeah, of course we can also slow it down a little bit. Yeah. Yeah, and this is a very, so when you want to get things moving that are not dependent on some environmental value, then this is one way of doing it. Yeah, so you can initialize initialize a value. This is the initial value, and then you can, I don't know, use the value, and then you can change the value that is then used in the next cycle. Yeah. The cool thing, of course, is also that you can make a component out of that very easily. Yeah. So I would like to have this rectangle because it's so nice and blinking. I would just like to, to extract that in some kind of component. And a component also is just also a function here. Yeah? So we are always composing functions and functions. There's always the same functions. There's always the same idea. Yeah? So I just say, bro, I copy that one. Yeah, I make a blinking rectangle. Yeah, and the blinking rectangle is for itself also just a scene. Yeah, I remove all that crap up here. I have here the yeah, just here the code that we had before. Yeah, and instead of this thing, I can yield the blinking rect. I mean, now that you just see a change in yeah, black's black's not such a good idea. Maybe we make it blue, yeah, and it's blue. Yeah, so this is a very, very easy refactoring. And I mean, now that I'm an advocate for F sharp, of course, is like uh, developing F sharp is all the way, all along is that easy as that. Yeah, it's really super easy. Just take some expressions, you extract them in something new, and that's it. Yeah. And now what else could we do? I mean, we have now one rectangle. We have only one rectangle. Yeah. Uh, but usually we refactor things out into a component, probably because we want to use it a little bit more often, not only once. Yeah? At least this can be a case. Yeah? So I would say the rectangle here, I just say X and Y. Yeah? I see X and Y, and I can say now 6 and 6, or I don't know, 2 and 6. Yeah? And the rectangle here is moved a little bit to the side. I can also move it a little bit up, and we see that. The cool thing also is, of course, I can just instantiate that thing, yeah, twice. No, or 4 times, or 5 times, or whatever, and then I have this kind of stuff. Yeah? And this is a very easy thing. So because if you would like to solve that with is using objects, yeah. So an object, yeah, it needs an address. It needs an address, a fixed address in a global address space. Let me say, yeah. So we have to create an instance up front, and that instance has to live. And then we would, for example, capture that instance in a closure, and that closure would be then a loop. Yeah. So we would also have to evaluate that instance, to tell the instance, hey, evaluate yourself. And that can be error prone. We had that in another talk, but here is always like, I just I just yield this thing as if it was a value. Yeah. I'm just yielding this thing, but it retains its own local state from evaluation to evaluation. Yeah. It is basically, yeah, as I just said, it retains its own local state. That's it. And of course, we could also yeah, or the fill. Let me say the fill. Yeah, we could have it here. Yeah, and I could say colors dot red and colors dot blue. Yeah, and yeah, this is now the concept of how can we make components and stateful components. Yeah, and this is always the same. This is always the same thing. Yeah, you just build some scene and you just use that thing in another scene, or you just send it directly to the simulator. So I could, for example, I could also send that scene directly to the simulator. No, this would also work. I could say, I just copy that line here. And I would just only have that thing. So there is nothing special with this scene. this is all the same. This is not more. This thing is not more special than that one. Yeah, we just have a function that gets some parameters and it yields evaluates to a scene. Yeah, we get back a scene, and in that scene we can do whatever. So we can build up and build up all that stuff that we want in a very easy way. Yeah, just by I don't know using these things here. Yeah? Of course, this can be done with a lot of other stuff. We can, for example, use Mark Druiker's wonderful California style outrun animated GIF, which is basically this. I make it a bit smaller, so I think this is safer with the. No, you have no hair. I would say with the. I would just say with the brown hair, but you have no.
I guess that's you or someone else, but not me, actually.
I would say here I'm the blonde and you are the driver, but you're. Yeah, you know, when we have sold 1 million clocks, then maybe go to California. But no, joking. Yeah, this is a wonderful wonderful gift, Mark. Thank you very much for that gift. This is very easy also to do. Not to load. Yeah, you basically you can just take an asset, you load it, you create some frames out of it, and then you say, hey, I want to have that GIF on whatever kind of position. Yeah, and render it. Yeah, this is an animated GIF. This is basically a list of frames. Yeah. And also here we have the idea that, okay, the list of frames, yeah, but which frame do I have to display now? Because there are a lot of frames. Yeah? And this image is also a state-aware function that retains its own state. The state in that case is just which GIF do I have to display and when should I display, sorry, excuse me, and when should I display the next one? Yeah? And there are much more examples. For example, we could have we could we could do it with a well-known friend, I would say. That well-known friend is by the way, Mark, thank you very much for your work. So Mark did this gift. This is a little bit more better. He did it for our purpose. So that was a really cool thing. Thank you very much. By the way, Mark also you can check his so he's very he's really doing great stuff. You know, he's doing a lot of stuff. Also pixel art, but he's also a programmer, by the way. I think programmer by day and an artist by night. Yeah, something like that. He has a lot of cool stuff on his homepage, pixel art things, and also his the company where he's employed is doing cool stuff. He's also a consultant. Yeah, just check out the things in Safari. His here all you see it's all animated. It's it's very cool. Just check out his services and his page. He's the A team. I like very much the truck driving through. Yeah, Mark, thank you very much. This is really cool stuff. Check out Mark Dulker's work and yeah. So again, we can load GIFs, and a GIF is basically also, you know, just a element that is animated, and we can also do it on our own. For example, I have some sprite map here from the Pizza Month. I always call him Pizza Month. You know, his month it means eat. Yeah, he's pizza eat. And you see here's just a sprite map with the ghost and so on. Of course, this is something that yeah, you know it. And what can we do? We can say, okay, we want to load an asset. This is just the ping, a static image. We want to crop it, and we want to make a sprite map. It just basically means 16 by 16 cell widths, and the duration is 50. And we get also, yeah, we get back a sprite map. And we can animate that sprite map. We can say, hey, I take the cell at 4, 0 and at 4, 1. No? So we cropped it a little bit, and 4, 0 is 1, 2, 3. Yeah, I don't know. 0, 1, 2, 3. 4, 0 and 4, 1. So these two red guys here. Yeah. We want to animate them. And then again, we just yield them at 0 and 6. And we see that this is, walking. Yeah. And for example, I could also take that. Yeah, and then he's going crazy with his eyes because here he's looking just in the other direction. That looks very poor boy. Something is wrong with him. This is better. So of course we could also yield another image. Yeah, we could no 6. How large is that? I don't know. 12 by 12, something like that. Yeah, and mm, yeah, now we see him also walking here. Yeah, so this is again the idea that we can really, I don't know, put a lot of instances of these guys on the screen, and they are all retain their state. Yeah, so this is again the same idea, not just that we do it with a list of frames and not with a self-drawn things. Yeah, yeah. Mm, of course, we could also say. This looks it's also not so super cool, but yeah, we can do much more with it. So we can from our sprite map we can extract the pizza month. This is the yellow guy here, yeah, um, who is hunted by his friends, let me say, yeah, and again, this is quite easy. I mean, no, we have refactored it a little bit. We have made a so our whole scene is made up with an offset, no? And this offset we are then animating, no? And the animation is again, when we had this thing here, we just incremented these values just by ourselves. But there is also a little bit more high level thing, which is an animator, and we can make a linear interpolated animation with a duration, start value, end value, and we can say, hey, should it repeat or not, and so on. Yeah, and this is something we can use here. Yeah, I don't know. I could also say ease in, so they are accelerating. Yeah, yeah, do a lot of stuff. So there is also some high level things that you can use with animations. There are also some logical helpers. For example, you want to say, hey, if the value goes from 0 to 1, then I want to have a trigger just for one frame. Yeah? So there are triggers and all the logical stuff here, slope up, slope down, and all kind of stuff. They are also they are not now you have some creativity things, For example, we have here our init animation that Sefa did. This is basically a map of 0 and no, an array, yeah, a 24 by 24 pixel array made up of 0 and 1 numbers. If you go a little bit away, you see that maybe. This is just, I take these values, I have some use saturation and other kind of calculations, and I just spit out the pixel array. This is animated in a, I don't know, faded in, faded out. This is just, basically 20 lines of code, something like that. Yeah, also, of course, but you have to have this data. Yeah, Urs is also using that in his animations. There are really a lot of ideas you can implement. Yeah, there's also, for example, we have a concept of layering. Yeah, where you can, I don't know, draw something on a layer, and then you can blend these layers, you can rotate these layers, and clip them and whatever and whatever. This is also possible. Yeah? Um, of course, you can also loop stateful things. So this is not a stateful thing now, but this would also be possible. You could really like do a stateful animation, and you use these stateful components in a loop. All that is possible. Um, yeah, and I think this is just a nice thing that you could try if you want. With I don't know, just your imagination. Yeah, it's just a thing. Okay, you could implement some shady effects. You could make some Faltung. How's it called? Faltungsfilter. Yeah,
I don't know the English term.
some a blur filter where you just clamp. Oh, what is the way is convolution. Yeah, convolution. I think is convolution is the word. Yeah, some convolutions filters. You can on all level of abstractions. You can manipulate the pixels, set the pixels. You can also for these drawn things you can get a bitmap out of it and manipulate them. There are a lot of things you can do. You can, for example, I mean, Urs will also show you some stuff right, that he does. He implemented a game of life. Urs, let me show this because this is also very nice. Um, just a game of life. Um,
With a clock face.
yeah, with the clock face. I mean, you could also you do not have to show to show the clock the time, yeah. But just I don't know, play Snake with an AI or something like that. This is up to you. Yeah, and now I would say, Urs, are you ready to show some of your work and show us how you what you did and how you did it?
I will try. A word of warning, I had some problems with my computer and screen sharing, but I switched my graphics card today, so I hope it will work. Otherwise, Zoom will crash and I will reconnect. Okay, yeah, I just wanted to show this game of life because when there is a grid, there needs to be a game of life. So that was our
Yeah.
first idea for a clock face, but it wasn't the first clock face we built because we just had to play around with the API a little bit first. And with every good F# program, we start at the bottom. We have the main scene.
Could you bump the font, please, one or two
Sure.
times? Yep, thanks.
We start at the bottom with the main, or it's called all scene. We also get the context, and yeah, this code was written together with my children. So they are, how old are they? 9 and 11. And they were for the creative part, and I was for the coding. So that was a mock programming session, and the code is not cleaned up thoroughly. But anyway, I think you will understand it. And one thing I have in my scene is the whole thing with the game of life, and I will also show the time and the date. And when we jump here, the live scene, now you see some things that Ronald has shown us. So the thing with the context, I also use a state, and my state is that the world, which cells are living and which cells are dead. So I hope you know the game of life. So there are rules when a cell comes to life and then a cell dies. We will see that later. Then something Ronald didn't show, I guess, are the triggers. So you can use triggers and say, okay, trigger if the minute changes, because on every minute I want to reinitialize the grid, because sometimes everything dies. So to have action on the clock, I reinitialize every minute, and I have a frame when I animate the new pixels, and that happens. What's that again? Milliseconds is twice a second. And I always calculate the new world, so which cells are living, which cells are dead. And when the minute changed, so you can just, if the trigger, then I initialize a new world based on the current day, month, hour, and minute, and I store it in the world state. And if I'm still in the same minute and the frame triggers, so twice a second, then I get the next step, the next evolution step in this world. Otherwise, I just keep the same world as before. And at the end, I write the pixels to the clock. I take this world, we'll see that's just an array. I map the array, because it's a Boolean array, to a color array and write it to the pixels. I need two colors, alive and empty, and for me it's much easier to reason in HSV values than in RGB. So I tried to use the built-in function, but it was buggy, so I built my own, but I guess it's fixed by now.
I'm not sure, but the repo is open source, so you can
Yeah, just add a pull request.
yeah.
Yeah. I spent 2 hours on finding that bug, by the way.
Sorry for that.
Sorry for that, and thank you for. But I think I took your code and already updated, I guess.
It was just a factor at the end that was missing.
Yeah.
It's the
Yeah. You told me, yes.
the
Yeah.
color hue, which color, the saturation, and the brightness, more or less. So the initial world, when I initialize a new world, I take the time and the date as the initial state. So, and Ronald showed us how to write text to the clock, so that's very easy. But what is not easy is to get the pixels, which are covered by the font, by the letters, by the numbers. So I had to reinvent the numbers. So here are all the numbers, just an array of numbers with as strings. The X means yes, there's 0. You should show the X and you shouldn't show the other thing. So,
By the way, sorry, may I interrupt you?
Yeah.
It is possible to get a snapshot of a layer or of the current scene just as a color array.
Mhm.
This is possible.
Yeah, but for me,
Yeah.
I didn't draw it yet, so it's not there yet.
Yeah.
So I just initialize my world. My world is just a Boolean array, so I don't have a two-dimensional array. I have a one-dimensional array with all the rows appended to the prior rows. So when I want to initialize a world, I get the numbers for the hour, the first number, the second number, same for minutes, for the day, and for the month. I draw these patterns above onto the grid, into my array. And I also write the dots between the numbers and the dates. So drawing a digit is, yeah, it looks more complicated than this. I can't even remember what this R means, so not perfectly cleaned up code. I can't remember, but yeah, when there is an X, you have to write a Boolean value true, otherwise you just leave it at false, because I create the array as a 24 by 24 times 24 array with false values. Yeah. So then I have initial word, and if I want to go to the next one, and that's the nice thing in F#, that is really easy. Gamify life in F# is really easy. So what I do is I go through every pixel or through every entry in the array of my world array. And first I create a new one, so it's really not memory efficient. It yeah, I allocate a lot of memory, but yeah, it works. Keeps on garbage collecting these things. And then I look for the neighbors. So I say top left is 25 position earlier than where you are at the moment. Because one row is 24, so I go 24 back and one additional one back. But of course, only if I don't hit the boundary. And then I say, if I don't hit the boundary, I know I have a value, so I have some value, and what is there? Is this cell alive or not? Otherwise, I have none. And I do that for all the neighbors. And then I take a list of all the neighbors, and again, that's really not efficient, but it was easy to explain to my children. I take all the neighbors and take all the ones that are actually existing, that are not outside the boundary. That's the choose one. Choose is only the one with some. Then I filter for the ones that are true, and then I take how many neighbors were alive. And that gives me a number. And with this number and the current value here, now I can code the rules of the game of life. So when you are alive and you have no neighbors, then you die. We set it to false. We are not alive. If you are alive, one neighbor, the same thing. If you are alive and you have 2 or 3 neighbors, you stay alive. Otherwise, you die. If you don't live and you have 3 neighbors, you come to life. Otherwise, you're still dead. So game of life is just, how many lines are there? 7 lines of code in F#. That's really nice. And I store the new value, and I return the whole new world. Yeah. I think that's everything in here. So it's a lot of line of code, but it's mainly because of this pattern here. And I think I can run that. I hope my simulator is still running. Yeah. So you already showed that. And one detail, colors on the simulator and colors on the real clock are really, really different.
Yeah.
If you, I guess that's the most time-consuming job, is to optimize colors so that they look nicely. But again, I'm not the artist. My daughter is. So she was responsible for picking the colors.
I can also I can try to switch my thing to the camera. I try to start the game of life. Yeah. But okay, again, also my iPhone camera. I mean, it really looks blue. Yeah, it also looks a little bit bluer here. But yeah, I think we have to do some gradient color correction, some curves with use gradient curves there.
Especially for dark colors. With dark colors, the effects are more severe than with bright colors.
Yeah.
But the nice thing is now, for a whole year, you have never the same game of life simulation, because it depends on the time and on the date. And when you let it run for a couple of days and you look at it, you see some really interesting things happen depending on which date or which time it is. So sometimes everything dies really quickly, and sometimes there are these stable patterns that emerge. So yeah, it's a real time hog to look at this clock face.
And if you, for example, if you comment out the rendering of the time and date, because I know you
I can do
need
that,
the
yeah.
rendering, of course, yeah.
So at first you see the initial world and then it's gone, so it's not really a helpful clock anymore. But yeah, it just shows the game of life.
I mean, our so as the device currently works, is also every quarter hour, not the clock is shown, but another thing is shown. Yeah, and so this game of life could also be you let it run for 1 minute, for example, as a intermediate sequence. Yeah, every quarter hour. Yeah, And this is also then quite interesting. Yeah, you have some oscillating. Ah, no, it's not oscillating. Yeah. Uh,
You have the stable ones like the square, then there are the oscillating
yeah,
patterns that have 2 or 3 states and then they oscillate.
yeah,
And sometimes everything dies.
yeah,
But
yeah.
it's not a real game of life because the real game of life would be without bounds. And of course, we just have a world of 24 to 24 pixels.
Yeah.
Now we are stable and really boring. So,
Yes, a very cool thing. This is a very cool thing. Yeah.
and just one thing, the the clock face I like most, and the one which I have running over there all the time, is this one. And yeah, if you do things with pixels, it can happen. You have to code a lot of lines because I have to set every pixel. So it's quite boring code and it's really tough to get it right. But yeah, it results in a nice clock. Just show it's this one. So we just do at every minute, the clock decides what should be the next color that I want to walk to when I'm back up at the full minute. So it decided to go somewhere violet. And because in the HS view color space, you can walk clockwise or counterclockwise. So it always takes the shorter route. And now it will, at the top, it will decide for the next color and it will walk there. And yeah, it gives a lot of different color gradients through the day. So yeah, you show the same on your webcam, yes.
Yeah. Yeah, this is definitely the also my favorite one. I mean, on the clock, it has really some these gradients, that you did, but they are really, really cool. Um, I mean, this shows me how what you can really do when you have some artistic talent, yeah, or if you focus really on that this thing is good looking. Um,
So my family is full on gradients and not sprites and animation.
yeah, 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 yeah.
Yeah, exactly. So your one is blue now, mine is now going to the greenish colors. Yeah, exactly.
Yeah. What I also find very very nice is Let It Snow. It's that one.
I can show. Yeah,
Yeah.
that was because we wrote most of these clock faces when we were on vacation in the snow. So yeah, so I thought, yeah, it was snowing outside, so it was in the evening. So that did one I built on my own. That yeah, I should have one where it is snowing. And if you look closely, you see when the snow lands, it turns into ice, and
Yeah.
ice turns darker the more ice is on top. So you can do a lot of so fancy small things with it. And also, if the slope is too steep, the snow will fall down.
Mhm.
Or it will fill up. It's just that it doesn't build these really high towers. Looks a little bit nice. Yeah.
Also, some variation could be so to have a continuous calculation for the snowflakes.
Yeah.
So, yeah.
I decided for all my clocks are concrete because I had a lot of problems with this. If you draw it in the middle, it gave a lot of flickering effects because
Yeah. Mhm.
yeah, this one is just it's always the bright white colors in a pixel. Otherwise, it dims out, dims in. So yeah, but
Yeah,
I
exactly.
built that on the simulator. I should try it on the real clock. Also, your idea of overblending colors didn't really work out very well. But
Well, yeah. What do you mean with overblending
yeah,
colors?
when you had the other clock here, I tried to that it's not a jump, it blends from one color to the other.
Yeah. Yeah.
And then there's a lot of visual noise when I try
Okay.
that. But maybe I need to do it. I tried 2 or 3 ideas how to blend from one color to the other with
Yeah.
SCP, with calculating the resulting color, and maybe I did some errors there. It didn't look nice on the real device, so I stick with that.
Yeah. Yeah.
But yeah, you can
Yeah.
lose a lot of time with experimenting, and it's really funny because you can try a little bit of code, let it run, and see the effects immediately. So that's something we programmers often don't have, this just visual immediate feedback, and that's a lot of fun.
Yeah.
So my kids liked it a lot because yeah, I have an idea, just run it.
Hmm.
Yeah, that
Yeah.
was great.
Yeah. Yeah, it's nice to hear that you had this such an experience. Yeah, and I mean also, so it should really make fun. So of course you're also a very experienced F-sharp programmer. Yeah, um, but in the end, I think so. It should just really be so from the way it works. It should be very intuitive. Yeah, so that you can really get started very quickly. Yeah, but still have the ability to use some higher level abstractions, like the animations and the state and all that kind of stuff. And I mean, there are some things in F sharp that are very good for that, but there are also some things that sometimes you have to be very explicit on the number types you have. Yeah, so ints and floats basically. Yeah, so um, it's
The
hard
one
to.
thing we struggled most was at first when we mixed state and functions. That became a mess quickly. So we really had to separate the function part, the pure function part, and the scenes and the states. So that was one learning we had because sometimes it didn't compile or it didn't show the frames correctly. So that's why my clocks are strictly separated, calculating the world or calculating the pixels and the scene with the state and setting the pixels again. It was one big learning
Yeah.
for us.
It's hard to imagine, but maybe after this thing, maybe you could, if you have in mind, explain what was the real problem, because I would like to understand that.
I can't remember anymore, sorry.
Okay. Yeah. Yeah. And problems is, of course, I mean, I've never seen a big or a non-F sharper programming, I mean, except of Sefa, my business partner. And also, this is very hard to understand how people think who are not in the game, let me say. Yeah?
Right.
It's really, you can try to predict some things, and maybe people will not understand this, maybe they will not understand that. Bye-bye. But it's always a guess in the end. It's always a guess. And I also hope in the Pixel Jam that there were some more people participating to get this information. Yeah. So what works for people and what does not work. Yeah. But yeah. So it's hard to get feedback on these kind of things. Yeah. Um, yeah. Yeah. Great. Yeah, there are some other nice clocks. Color Rain. This is also something I like very much. Um, I also like that is the mountains and the sky changing according to the time. Yeah, this is also something that is really can chill. It's a chilling thing. Yeah, and of course I love that.
Yeah, that was the first clock face of my son. So at first he just drew a 24 by 24 picture and he didn't realize that he could animate it. So it's just the picture and then we introduced some animation and that the dog walks. But yeah,
Yeah.
It's a very inefficient way of animating something.
But you know, I also find it so lovely with the palm tree, yeah, and the
Yeah.
sun and so on. And this is really I mean, I also when I was a kid, I loved these side scrollers and with parallax scrolling effects and so on, and all that kind of things. That maybe is also. I mean, it's only 24 by 24, but I think it's really possible to do some cool stuff on that thing. Yeah, and you showed that this is possible. Um, yeah. So yeah. All right.
Should
So
we wrap it up? Or
I would say so.
yeah,
Yeah.
okay.
Thank you very much for participating.
Yeah, thanks for the session. There were some positive comments like kudos and yeah, just compliments for you guys. But no more questions as far as I see. So yeah, with that,
I just want to chime in and say I think that emulator is really cool. That's a really, really good addition.
The what is a good addition?
That emulator where you can kind of
Ah,
see the pixels
yeah,
and be able to like program, right there. That's a really nice addition.
yeah, yeah. This is yeah. We will see how this all works out. Yeah, we are very curious. I mean, in the end, people should have fun with the thing. Or I mean, also you can just let it on your on your cupboard, for example. Yeah? You place the device there and just have a clock and every quarter hour a nice animation, something like that. Oh, we are experimenting and yeah. So we will see where all this gets. Yeah. All right. So thank you very much for participating and yeah, hope to get feedback and to see you soon.
all right. Thanks again. And yeah, most likely next week will be another session.
We'll
Yep.
see all this.
Just just check the socials and the website. Right. Bye bye.
Bye.